For example, in 2015, the gross merchandise volume, GMV, was 91.2 billion RMB. In 2016, the GMV was 120.7 billion RMB. And most recently, in 2017, the GMV reached a total of 168.2 billion RMB. Behind these enormous sales figures is the solid foundation of Alibaba's mid-end data platform. From a unified approach to marketing to personalized recommendations and real-time computation and visualization, a solid mid-end data solution has created new possibilities for Alibaba. Several years ago, Alibaba faced many challenges, including data silos, data duplication, and contradicting data metrics. As Alibaba navigated through these complex issues, the group developed a unique data mid-end, which is a unified data platform to develop and manage data asset for the entire Alibaba group. That framework has since been turned into DataFin, Alibaba's data platform as a service, PaaS, that provides industry clients one-stop tools, data technologies, and methodologies to help customers build their own data mid-end, transforming their data from a business cost to commercial value. Let's look at how DataFin works in 6 steps. First, DataFin provides a data warehousing architecture service to internet companies, traditional businesses, and government entities. Users can leverage DataFin to model their complex business portfolios into well-structured data domains. The resulting robust data model architecture is the first step towards successful data asset development. Second, DataFin provides a data synchronization service. Regardless of data complexity, DataFin's superior flexibility supports cross-device, cross-format, and cross-domain data synchronization requirements. Third, DataFin provides complete and executable warehousing field definitions, visualization design, and automated code generation capabilities. While the toolkit enforces structured metrics, the automation features significantly improve development efficiency. Fourth, DataFin's unique data distilling module can simplify algorithm development for crucial business entities. Embedded algorithms, including machine learning, visualization, and modeling, DataFin turns complexity entity identification, relational linking, and profiling development work into simple drag-and-drop operations. This capability can be rapidly tailored for all types of business needs beyond consumer profiling. Fifth, DataFin simplifies data access by allowing users to look at data from a business perspective, with theme-based logical data depiction that is automatically generated and based on metadata. Businesses no longer need to be concerned about complex physical data tables. Finally, DataFin provides unified data asset management, helping users to gain a clear view of their data, rapidly search and use the data, smartly optimize data computation and storage efficiency, trace data applications, and most importantly, measure the overall cost and benefit of each data asset. Notably, all features are housed within an easy-to-use interface, and artificial intelligence is continually being used to optimize processes. With DataFin, users no longer need to worry about technical complexity. They can simply follow the 6-step journey to build a well-structured and organized data layer, a unified data common layer, and rich diversified data application layer to achieve data standardization, development automation, asset-based data management, and data intelligence-driven business. DataFin has helped a variety of businesses within the Alibaba ecosystem to achieve success in retail, finance, and logistics. It has also supported other sectors such as media, technology, and government. With DataFin, the Chinese streaming video company Youku Tudou improved its computation efficiency by 4 times.
Welcome to the first CloudCast radio session, where we will be discussing hot topics in cloud computing, how they relate to the industries, and also how they relate to Alibaba Cloud. Today in the studio, we have Alberto, a Spaniard living in Australia, who is going to be talking with us about networking containerization. So, welcome, Alberto.
Thank you, James.
Could you give us a little background on sort of who you are and what you're doing now?
Yeah, so well, the welcome message was correct. I'm a Spaniard living in Australia right now, and yeah, basically my job is completely centered in infrastructure, in containers, in well, all this cloud thing going on. So yeah, I think we can enjoy a good conversation today.
Great. So yeah, let's just jump into it. So networking containerization, it's a mouthful, container networking. First, let's just go through sort of the definition. First of all, what is a container? And sort of, is it different than any other storage device?
Well, containers, I guess we can, well, I think this is better explained to the people who already knows what's a virtual machine and is running into all these issues with virtual machine because the size and resource allocation. Depends how, like, to whom you're explaining what is a container. The definition varies a lot, but definitely containers is something that it really works really well with cloud right now. Is something you can use to ship applications. It's not a storage type. It's not something for just for networking. It's not something just for computing. It's just a solution you can use for pretty much everything if you want to package an application and run it anywhere.
Right. Okay. And so, how does it network? What's special about networking containerization? Seems like you're sharing containers across the network. What is that? What is special about this?
Special about, I guess, the biggest challenge there in what we have in our industry in a daily basis is when a developer writes a piece of code and then he needs to test the code that is working, and then the QA team needs to test that everything clicks and everything works and all the screens that are shown, nothing crashed, and then okay, you push that changes to maybe a staging environment or production afterwards. And I'm telling you, in the past, I was doing this without containers, just pushing code straight to the servers and keeping 2, 3, 4 different servers in a similar state with the same packages installed, with the same, trying to keep the environments as similar as possible, but you always miss something. So sometimes whatever works in your local machine, it doesn't work in production, and then it crashes, and then the client is angry.
Right.
So I think the best thing the container does is keeping a consistent environment across environments, and if something works in your local machine, well, it's very likely that it's going to work in production.
Right. So when you're talking about environment, are you talking about operating systems exclusively, or what are other factors in an environment that might affect a non-container networking solution?
Yeah, that's interesting, the environment definition. I guess everyone will have a different explanation. For me, environment is everything that surrounds the code you're pushing. It can be a different database you're connecting to. You can have a testing database, or you can have what you say, an operating system. Like maybe a developer likes Windows, so he's developing everything in Windows, but then the testing team is running Mac, and then everything at the end of the day you upload it to an Alibaba cloud server and it's running Linux.
Right.
So it needs to work in the Windows machine of the developer, in the Mac of the team, and then in production in Linux.
Right.
So yeah.
So, and in the platforms that you use to debug code or even write code, just the software itself, could that cause sort of environmental problems as well outside of the operating system?
Yeah, anything like I've been thinking about problems we have in the past, not even something that you will never think it will affect how your code is running. And then it causes a strange bug that it takes hours or days to track down, you know?
Mm-hmm.
So it's just all that stuff is pretty much gone with this technology.
Right, right. So that sounds like huge positives to using containers. Are there any
Definitely.
downsides to using containers? Is there any reason you wouldn't want to containerize your applications?
Well, Alibaba Cloud actually runs into these issues with containers
Mm-hmm.
sometimes. For example, in Alibaba itself, when they need to run systems that actually process financial transactions, by the nature of it, containers, well, with containers, let's put it in this way, it's easier from one container running, see what another container running in the same machine is doing.
Okay.
So you need to be really careful with this.
Mm-hmm.
So yes, if you are using any financial transaction or something very, very delicate, you either use an external server to process the data, or you better run with virtual machines in this case. But the vast majority of us, we never process financial transactions. We always use external services like Stripe or PayPal, you know. We
Right.
don't really, we don't deal with that sensitive things. It's better to just leave them away. Yeah.
Okay. So sensitive data is not something you'd want to put on a network just because of security issues?
It's something you can definitely work with in containers,
Mm-hmm.
but if you're not very experienced, I wouldn't recommend to use this for that very sensitive situations. If you are very experienced and you know what you're doing, yeah, sure. But still, even for the very experienced, there is some gotchas.
Right. That leads me to a question of what's the learning curve of sort of adopting a containerization method for your applications?
In my case, was quite steep,
Uh-huh.
but I'm not sure if it was because I didn't really understand it, or it was maybe because I got into containers quite early, like it was more than 6 years ago.
Right.
But yeah, I remember the main thing that I would, I guess the main thing I learned, the hardest thing for me to really feel, okay, I know how to how to run a container, is the fact that a container runs one service, and when that service dies, the container itself dies. This is different from running a virtual machine or directly a computer. When the operating system itself is running, if you run an application on top of it and the application dies, well, the computer doesn't crash, it doesn't break. You just restart the application. But in a container, the whole container dies. So I guess this is the most difficult thing I faced back then to learn. Yeah.
Right. Right. And when a container dies, what's the solution for that? Do you have to rebuild it? Do you have to reinstall the application into it? I mean, what kind of process is that?
Yeah, so the good thing for containers is you already pre-package a Docker image. So everything is already ready to be executed within seconds. So if the container dies, for example, if you are running a cluster in Kubernetes, Kubernetes itself, you can tell him, you can tell Kubernetes with a config file what to do if your container dies. For example, you have a container that needs to list how many countries are in the world. Well, when that process finishes, you don't want to run it again. You just want the result, and that's it. So you can tell the system, no, when it dies, if it's not failing, just it's done. If it failed, restart it. Or if it failed, don't restart. Like there's a lot of different situations, or whatever happens if a container dies, just restart it. You can tell the management system of the container what to do in that situation.
Right. Okay. So on to some real world examples of how containers are used, maybe practically in a business environment. You said you are part of what you do now is working with containers and networking with them. Could you give a brief example of using containers in a business environment that people might see?
Hmm. Yeah, well, apart of running the actual application itself, that's the most basic usage I can think of. I can think up to three main uses let's say I see on a daily basis.
Mhm.
One will be container to container connections. For example, you have a PHP application, which is the backend. It processes whatever you want to process in that application. But the users, the visitors to your website, they first face a web server, which is a container itself. And then that web server, when it needs to process PHP, it connects to another container to, well, to really has the interpreter of the PHP. That container renders the page or does whatever it does with the logic. It returns the information to the web server, and then the web server container, it relays that information back to the visitor. That's
Mhm.
one of the probably most common uses of containers, just to talk between each other, to really gather all this information, to really give it back to the visitor. Another two uses I would say is to deal with the SSL certificates. You can put a container facing the internet. So when someone visits your website, that container responsibility is to make sure that the website, it has the proper SSL certificates for that domain, that they they are not expired. You need to renew, for example, using external services like Let's Encrypt. So it deals with that for you. So your application really runs in the port 80 internally. So you don't really need to care about encryption, about strange port or anything like that. So that's really cool. And another use, which is also very common, it will be a reverse proxy. So a server, a virtual machine, for example, is running 10 containers, but only one container is exposed to the internet. The rest of containers, they're completely isolated. And so depends of the request. Depends the request coming from the internet, from a visitor. The reverse proxy knows to which container to proxy that request, and then they will keep the process back to the proxy, and the proxy will give it back to the visitor. So that will be pretty much the three most common situations using backends, SSL management, and reverse proxies.
Right. And would you say that with the biggest players in the IT industry and other industries, this would be their three main sort of applications of containers?
I would say so. Like at least I deal with in the last year, I dealt with more than 40 or 50 different applications, different complexities, and this is the main three that they're always there. Yeah.
Nice. Okay. And so it seems that the containerization is a part of a DevOps workflow. DevOps is kind of larger system architecture. What role does it play in there? Does it, is it part of the testing phase? It's part of the transfer phase. Which phase of the DevOps workflow would you see containerization being used?
This is an interesting question. As um, as we were talking in the beginning, the whole point of DevOps itself is DevOps first is developer operations. So anything that has something to do with the code that the developers run, and then how that code runs finally in the production and how that is scaled, this container thing is so nice because it just makes it easier in a team to develop and deploy applications. Like for example, like as we were mentioning, this container technology lets you package an application and run it everywhere, no matter the operating system or the cloud provider. And by using layers, which you have in Docker, this thing called Union FS, the Union file system, which is the technology behind the the Docker layers. So when you ship an application, in most of cases, you just ship a Docker file, which is just one text file.
Right.
Maybe a couple of other files for the code base, which is just a couple of, like, not even, just a couple of kilobytes, if it reads that, and that's it. So in the other point, it can be the other point, like another location in the planet, they just run that Docker file, they download the Docker layers that Docker file needs, it copies the code on it, and that's it. So it's so easy to send, to deploy, you can even send an email with a whole application, just everything in the email. So it's just amazing.
Right. Right. Yeah. So it seems to be a crucial part of that, sort of having you not repeat things a lot. I think that's sort of the DevOps mentality to begin with. It seems like containerization is a big part of being able to make that flow a little bit nicer. So as far as platforms that provide containers, what are the big ones, and what are the differences between them? Are they separated by sort of uses, or are they very similar?
From my experience, I would say AWS, Alibaba Cloud, and Microsoft Azure. They are, for me, the best providers, at least in terms of containers. Again, from my experience, where my experience tells me that Azure and Alibaba Cloud, they're the ones offering the most robust products, especially with Kubernetes, as they kind of respect the standards more than AWS in this matter. Like you can read a lot of documentation of how to build something in Kubernetes, right? When you go to Azure or Alibaba Cloud, it just works. But when you run that in AWS EKS, which is the solution, it's very common to run into some non-standard issues.
Okay.
So I would say Azure and Alibaba Cloud, they are quite good on this, yeah.
And does it matter where sort of the servers that you're using are based? Is it more convenient or more, I don't know, there's less errors if you're closer to the database where you're storing your things? For example, people in Southeast Asia, Alibaba Cloud has many more databases in that area. Is that something more reliable, or that doesn't really matter?
Well, of course, like if you need to deploy something in South Asia, especially in China, well, the provider to go is Alibaba Cloud. Like you can just run a container in the same network as your database, and there is no firewall, there is no network problem that is going to prevent your application from running straight. For example, even if you run a CN connected to an AWS from another country to improve that latency issues, still, like, you will need to, in this case, yes, I completely agree. You will need to use Alibaba Cloud.
Yeah.
In other countries, I guess it depends your location.
Yeah.
But here again, Azure and Alibaba Cloud, they are doing a lot of efforts to relocate data centers all over the place. Of course, AWS in Europe is pretty good.
Mm-hmm.
But
Yeah.
yeah, depends your requirements.
Right. I hear a big name in the containerization world, Docker. It's the logo with the whale and the the, the boxes on top of it. And this is a smaller service provider. It's a OS level virtualization deliver software. Is this this seems specifically for just containers. Is it better to use a larger service like AWS or Alibaba Cloud because you can incorporate a lot of different products together into it, and that makes it more useful than just using Docker? Or are there things that just using something like Docker or just using a containerization sort of software like this can make it easier, I guess that's.
Yeah, so well, Docker came into play in a really good moment. They developed a great product, and you can run Docker containers anywhere. In Alibaba Cloud, you have container service, you have Kubernetes, well, managed Kubernetes, but DigitalOcean also gives you managed Kubernetes. You can run a Kubernetes even in your local machine. You can run it pretty much everywhere. Here, I would say that if you want to go a bit further than just containers and just using Docker, I will recommend people using Pouch Container, which is Alibaba's own container engine.
Okay.
And it's fully compatible with the OCI standards, which includes the Docker images. And the benefit of this is I say this to whoever wants to play a bit more than the normal, but Pouch Container lets you run container images as a virtual machine, which is here the game changer. Sorry, the game changer really.
Right. So just sort of to look specifically at Alibaba Cloud for a user that wants to do some of the operations that you've been talking about with containerization. What do you need to get started? You certainly need a virtual machine, but what are other tools that Alibaba Cloud offers that makes this process more secure and reliable?
In Alibaba Cloud, I can think of 3-4 different situations you can run your containers. One will be the most classic one. You just start a virtual machine, an ECS instance in this case, and you install Docker on top of the operating system, and that's pretty much it. You just bring your Docker file or your Git repository, and you just run it. But I mean, this is good to run one container and keep it a bit and manage it a bit in a manual way. The second situation I will think is run directly with container service. So Alibaba Cloud offers you the possibility of running a Swarm cluster or a Kubernetes cluster. They're both completely open source projects. The documentation is just massive. It's everywhere. It's all over the place. Kubernetes right now is a lot more popular than Swarm, but you can just use that two services. The only thing you need to do is you need to create a virtual machine with the clustering, which Alibaba Cloud creates everything for you, and then you just bring your containers in using the API of Kubernetes, or just Swarm by using your local Docker Compose config files. And the cool thing about this, which I found out last year in the computing conference in China, is that you can run serverless Kubernetes, which is I think the best thing it ever happened to containers. So yeah, I will say that 3 or 4 situations. Yeah.
Yeah, serverless is a whole type of conversation that I'd love to dive into some other time. I think it's a whole nother thing. But I think the combination of containerization on the serverless architecture is certainly where things are going. When it comes to, I know you were mentioning this earlier in the conversation about sensitive data in containers. So, networking obviously comes with risks, security risks of people getting into your stuff. How does containerization protect you, or does it not very well? And if it doesn't, what kind of measures can you take to make sure that if you are passing maybe not sensitive data, but even sensitive applications that you've built, or something that you've created yourself that you don't want other people to see. How do you make sure that this is a secure sort of network that you're building?
Well, from a fully networking point of view, that's really good because by default, even if the container is exposing ports, by default, when you run a container, it doesn't expose the ports outside of the host, which in this case will be the running operating system. So yeah, like even if your computer is completely exposed to the internet, your containers, so someone outside, it won't be able to connect directly to one container. So in this case, the example I was putting before of the usage of reverse proxies, where you can run, I don't know, 10, 20, 30 containers in your host, but then there is only one door that controls the access to each of them. So depends the request, it knows where to direct the request, and then a container will process. Even if a container doesn't really, is not even able to connect directly with a visitor directly through a reverse proxy, it can be accessed by an indirect way. For example, you request something to one container, and then that container use another container as a processing as a processing application. But someone from outside won't be able to really access directly to that one. So I think by default it's pretty good already.
Yeah. Can you give permission to anyone that you would want to access it? If you wanted to share an application sort of to a massive network, could you give certain people rights to see it and then certain people not rights to see it? Or could you make it completely public? I want to go on, Pirate Bay and share some application or something like this. I want everyone to have it. Are there restrictions, for those sorts of things? How does sharing work?
Like, for example, if you want to just open everything to everyone, the easiest thing you can do is just, if your container is exposing the port 80, which in this case is the HTTP port, you just link the port 80 of the container to the port 80 of the host. That's it. Everyone will be able to access directly straight away, straight to the container. If you want to hide it, then, well, there are multiple approaches to this, even from a purely software approach, where you just have a login page and then you have a database to store that information, and the database can be a completely different network or even a different machine of the container, and then no one will know really. So you can really hide and put as many layers of protection as you want from a network and from a software point of view. So yeah, it's limitless, really.
Yeah. I mean, I imagine that sort of within a company would want to share some software between all the employees, but not let people outside the company see that. And I imagine there would be a sort of neat solution for that, the way you just explained it.
Yeah. Well, for example, in my company, the way I let developers access to our development and staging environments, it's by putting a VPN container in front of all our protected environments, or our safe area.
Right.
So if you're connected with a VPN to that container,
Mm-hmm.
then you have access to other containers because they have rules that only this range of IPs and only these host names, they are going to have access to these services. If not, it's like doesn't even exist. It just times out. So only if you're connected to that container, you will have access to, well, to all our stuff, to be honest. So even
Yeah.
if you're at home, you connect to that VPN, that's it. You free access to everything.
Right. Right. Yeah. Um, so I guess sort of my final question is, where do you see the future for containerization, networking with containers? How do you see this becoming something that the internet community will, become stronger because of? It's still, fairly new technology. You said 6 or 7 years old. I think there's not a lot of people outside of maybe IT departments or developers themselves that are familiar with how to use it effectively. Is this going to be something that is more public? People know more about it. People that are not into IT will be setting up containers for practical things that sort of the everyman would be doing. And what would that look like in your mind?
I think the hardest thing to someone, like for someone to really implement containers or make use of containers is, is really to set up the whole thing around a container.
Right.
So you need to set up the host, the virtual machine, you need to install Docker or Pouch container,
Right.
you need to set up so many scaling rules. So like it just any system, every system is different. You need to set up even a volume because your website deals with uploads, right? So that uploads, they need to go somewhere, and that volume needs to be persistent. So even if
Yeah.
the container crashes, the data needs to be there, can't really die with the container.
Right.
So I think if you asked me this 2 years ago, I will
Mm-hmm.
tell you that the solution to this, it will be approach this from a serverless point of view,
Right.
because you really don't need to provision anything. You just upload your definition of the container to somewhere, a
Mm-hmm.
place, and then that somewhere it will run the container for you with just a little config. But right now we're in 2020, and just like Alibaba Cloud offers serverless container service, which
Mm-hmm.
is great. You just push your containers and that's it, and they do everything for you. It's so easy now. So I
Okay.
think we are already in that future. I would think is the holy grail for the
Okay.
for the
The
containers.
the future is already here, right?
Oh yeah, now I guess now we need to polish it because there's still a lot of
Yeah.
things to polish. But yeah, the config will become easier and easier for the average user, I'm
Yeah,
sure.
yeah. I think the user experience is always something that sort of comes last with technological developments. I mean, you could think about setting up a bucket, before, and how complicated that must have been
Oh
when
yeah,
when it was raw. And now you go on to Google Drive and you drag and drop
yeah.
files. You don't even need to hit an upload button. You drag and drop, and so that
Oh yeah.
user
Some years
experience.
ago,
Yeah. And
yeah,
some years ago, this is just ridiculous to think of. So I've sort
yeah.
of
Think about
imagine
yeah,
everything that we do going that direction. Where it all becomes
totally,
super drag and drop.
totally. Yeah.
Wouldn't we love that? Because then we don't have to study all these complicated things anymore.
So then what? I lose my job. No, no, no.
No.
I
You build it. You build these things. This is your job to build the user experience.
Okay, okay. I need
You
to
know.
justify my job somehow.
No, well, someone needs to know the background so they can build these
Yeah,
sorts of
yeah.
things, so that people that don't want to learn about it do not have
Okay,
to. So I think
okay.
that's still very important. Yeah.
So it's still safe. Yeah,
Yeah, you're safe. You're safe. You're
yeah.
definitely
Okay.
safe. You're safe. Cool. Is there anything else you'd want to add?
I guess if you didn't jump into this technology, you are missing out. It completely is all the development processes around an application.
Mm-hmm.
And yeah, like I recommend anyone to just start playing with the build commands locally, play with the ports, and then just push something you created just to the Alibaba Cloud Service and see how it goes.
Great. Well, thank you for speaking with me today, Alberto. And we hope that these cloudcasts are going to be helpful for people and help them understand the better uses of containers and why they should be using them, how to use them better. And in the links below, we will provide more information about documentation and some more use cases so that people can jump right into it. But your enthusiasm is clear. And we hope that we hope your enthusiasm gets passed on to the people listening.
Well, James, thank you for inviting me to this program. I really enjoyed the conversation with you.
Great. We're signing off.